Here are a few additional examples for you of scientific notation. These will end up to be a little bit more challenging because a couple of the problems you'll have to change the final answer to scientific notation in the end, and there will be an explanation of why and how you do that. The best way to practice, pause the video now, go through these problems on your own to the best of your ability and show the work that you can. And fast forward to the very end and see if you got it right. And if you made a mistake, go back and listen to the explanation in the video and see why. So going to the first one, we're adding these two numbers together in scientific notation. They have to be like terms in order for you to add them up. And in algebra, like terms means you have the same variable and the same exponent attached to your number. But in this example, because we're using scientific notation, we're multiplying it by 10, and we have the same exponent on both of them in order for them to be like terms. So because they're both times 10 to the third, it just works. So we're going to add up these two numbers, and I get 14.53 times 10 to the third, because whenever we add our like terms, we want our exponents to remain the same. However, our final answer, as you can see, is not in scientific notation. It's not just this 10 to the third that makes the number scientific notation, it's this value right here. This value, in order for it to be in scientific notation, needs to be a one-digit number, possibly with a decimal in the end. And in this circumstance, we have a two-digit number, 14. So what we actually need to do is we need to move this decimal back to make it a one-digit number. So we'll end up with 1.453. And by moving it, we're going to end up with a new exponent. And the rule that I have that has always worked and always helps is if you're making your decimal bigger, you have to make your exponent smaller. If you're making your decimal smaller, you have to make your exponent bigger. So going from 14 to 1, I'm making my number smaller by one decimal place. So I'm going to make my exponent bigger by 1. So this would get me the final answer. It also works if you had to move the decimal over 2 places and make this number smaller by 2 decimal places. You would have to increase your exponent by 2. So moving on to the next example, you can see there are no symbols in between these parentheses, which implies multiplication. So we're going to multiply these two numbers, and I got my calculator here with me to help me out with that. And that gets me 7.24 if I round using the correct amount of significant digits. And then whenever we multiply, what we'll have to do is we'll have to add the exponents. So we're going to take these exponents and add them up. In algebra, if you have variables with exponents and you're multiplying them together, you add the exponents because it gives you the total amount that you're adding together. So, for example, we have -3 tens that we're multiplying together, and then we have 10 tens that we're multiplying together. 10 minus 3, or -3 plus 10, gets me 7 tens. So I will end up with times 10 to the 7th. Now that whole multiplying, whenever you multiply, you add the exponents, that is just something you have to memorize. That's just something you need to know, and it goes back to your basic algebra knowledge of what to do with exponents when you're multiplying numbers. And remember, it only works when your base is the same. And for scientific notation, it works every time because your base is always 10. So again, when you multiply, you're always adding exponents. That's just something you have to have memorized. And it's the same exact thing for when you're dividing. So in the next problem down here, when you're dividing, you have your 8 and your -5. You're going to have to subtract those numbers. And that's just something you have to have memorized. It's just something you need to know through practice. So I'm going to divide my decimals, 1.66 divided by 7.98, and that gives me 0.208 if I use the correct amount of significant digits. Times 10, and I said before, whenever we divide, we have to subtract our exponents. It's not 8 minus 5. Remember, we're subtracting the entire number. So it's actually going to be 8 minus negative 5. So you're subtracting these numbers no matter what, if there's a negative in front of it or not. So this means we're going to get a total of 8 plus 5 as our new exponent, which is 13. But remember, in order for this to be scientific notation, this has to be a one-digit number. I need to change my decimal so it goes between this 2 and this 0. That way I get a two-digit number. So I get 2.08 times 10 to the something. And here's how I figure out that something. I'm making this number larger by 1, so I'm going to make this exponent smaller by 1, and that gives me 12.